Right now, the room around you is dark, or nearly dark. But here is something strange. Unless you have stood deep inside a cave, or sealed yourself in a specially darkened room, you may never have experienced complete darkness in your life. Not once. Tonight, we are going to find it together. We will travel from the shadow behind your closed eyelids to the 2-week night of the moon, past the dim twilight of Pluto, into clouds, so black that a great astronomer once mistook them for holes torn in the sky, and finally into a region of space hundreds of millions of light years wide, where there is almost nothing at all, a place so empty that a civilization living inside it might not have discovered other galaxies until well into the space age. Some of what you will hear tonight is genuinely unsettling. It comes from real observations and published science. And where the science is still uncertain, I will tell you so plainly, and, by the end, I think you will find that the darkness of space is not something to fear. It may be the quietest gift the universe ever gave us. So turn the lights down, get comfortable, and let us begin with the darkness you think you know. Think back to the darkest place you have ever been. Maybe it was a bedroom in a house far from the city, on a night when the power went out and the whole neighborhood dropped into silence. Maybe it was a tent in the mountains, long after midnight, when the campfire had burned down to a faint orange memory. Maybe it was simply a hallway at 3 a.m. When you walked from one room to another with your hands out in front of you, trusting your feet to remember the floor. Hold that memory for a moment. Whatever it was, it felt like darkness. Real darkness. The kind of dark that makes you slow your steps and listen harder. Now, here is the first honest surprise of the night. That darkness, the deepest one you can remember, was almost certainly not dark at all. Not by the standards of this planet, and nowhere close to the standards of space. If your eyes could speak, they would tell you that even in that room, even in that tent, they were still catching light, a faint glow leaking under a door, the pale wash of a distant street lamp on the ceiling, the soft grey shimmer of a night sky that is never quite black anymore. Your eyes found something to work with, because on the surface of the modern Earth, there is almost always something. We are a species that has quietly erased its own night. This is not a poetic exaggeration. It is a measured, mapped, published fact. In 2016, a team of researchers led by an Italian scientist named Fabio Falchi published something called the World Atlas of Artificial Night Sky Brightness in the journal Science Advances. They combined satellite data with thousands of ground measurements to build a map of how much human-made light now fills the sky over every part of the world. And the numbers in that atlas are the kind you have to sit with for a moment before they fully land. According to that research, more than 80% of the world's population lives under skies polluted by artificial light. In the United States and in Europe, the two places where many of you are listening tonight, the figure rises to about 99%. And when the researchers asked a more particular question, who can still see the Milky Way, our own galaxy, from where they live, the answers split by continent. Around 60% of Europeans can no longer see it. In North America, the number is close to 80%. 4 out of 5 people on that continent have lost sight of the river of stars that every single one of their ancestors could simply look up and find on any clear night. It is not that the galaxy moved. We turned on the lights, and we never turned them off. For almost the entire history of our species, darkness was the default. Night was not something you visited. It was something that arrived every single day, total and unarguable, and every human life was arranged around it. Then, in barely more than a century, roughly the time between your great-grandparents and you, we wrapped the inhabited world in a permanent dome of glow. If you were born in a city or a suburb in the last 50 years, there is a real chance you have never once stood under a fully natural night sky. The true face of the night, the one your own eyes were literally shaped by evolution to receive, may be something you have never seen. It is not a tragedy. Exactly. The lights that dimmed our night also lit our hospitals and our streets and our kitchens. And no one is asking you to give those up. But it does mean something quietly remarkable. Darkness, real darkness, has become one of the rarest experiences a modern person can have. Rarer than seeing the ocean, rarer than snow. Whole industries now exist to help people travel to the last dark places on Earth. Just to look up. We will visit one of those places ourselves, much later tonight, when we have earned it. First, though, a more curious question. What actually happens to a human being in total darkness? Not the almost darkness of a bedroom. The real thing? And it turns out we know the answer. Because there are a few places on Earth where something close to total darkness still exists. And people have gone into them. Deep caves are the most honest example. In a place like Mammoth Cave in Kentucky or Carlsbad Caverns in New Mexico, tour guides sometimes do something simple and unforgettable. They gather everyone in a chamber far from the entrance, and they turn off every lamp. What follows is a kind of darkness most visitors have never met. You can hold your hand directly in front of your face and see absolutely nothing. Not a shape, not an outline, not a difference. People often report that after a few moments they lose the sense of where their own hand is. The eyes strain and open vida and search and find nothing, because no usable, visible light reaches them down there. For the purposes of human sight, the chamber is complete darkness, and the experience of it is unlike anything on the surface. And then something even stranger happens. Given enough time in that kind of darkness, the human brain gets restless, deprived of any real signal. The visual system can begin to generate its own. People start to see faint drifting patches of grey, slow-moving patterns, soft blooms of light that are not there. This experience is common enough that it has an old informal name. It has been called the prisoner's cinema, because accounts of it go back to people held for long periods in unlit cells, who described watching lights and shapes bloom out of the blackness in front of them. Scientists who study perception generally describe these as harmless illusions produced by a visual system with nothing to process. The brain essentially filling silence with its own quiet noise. The finer details of why it happens are still being studied, but the basic fact is well documented. In total darkness, the human mind refuses to accept total darkness. It starts painting. Notice what that tells us. Darkness is not just an outside condition. It is something your brain actively negotiates with. Your eyes are not passive windows. They are instruments that were built over millions of years for a world where night was absolute and light was precious. Your pupils can widen to let in roughly 16 times more light than they accept in daylight. Given about half an hour of real darkness, your retinas shift chemistry entirely, switching to cells so sensitive that, by some estimates, a healthy, dark-adapted eye under a perfectly black sky could detect the light of a single candle from miles away. You are carrying, right now, behind your closed eyelids, a pair of precision instruments tuned for a darkness you have possibly never given them. Let them rest for a moment. If your eyes are still open, notice how little they are needed right now, and how willingly they soften when nothing asks anything of them. That softening is old. Every human being who ever lived has felt it at this hour. And that is the first quiet idea I want to leave beside you as this journey begins. We are going to spend tonight traveling into the darkest places that exist. And I told you honestly that some of them are unsettling in their scale. But the darkness itself is not a stranger. It is the original condition. It is what your eyes were made for. What every night of Earth's 4.5 billion years was made of. Before this one bright century, the darkness you crave at the end of a long day is not an absence of something good. It is the return of something old. So here is where we stand at the end of this first chapter. You now know that you have probably never seen complete darkness. You know that it still exists, in deep caves and in the last protected dark places, and that your own body is secretly built for it. But every example so far has been here, on the surface of one small, warm, well-lit planet. The real darkness, the kind this night is truly about, begins where the planet ends, because there is a question you have probably never asked. If you left the Earth right now and rose up past the clouds, past the last thin breath of the atmosphere, into space itself, in broad daylight, with the sun blazing right there beside you, what color would the sky be? The answer is black, perfectly, permanently black, in the middle of the brightest day, right beside sunlight strong enough to burn you, and hiding inside that blackness is a question so old and so deep that one of the first people to answer it correctly was not an astronomer at all. He was a poot, and you already know his name. So there you are, in this thought experiment, floating above the atmosphere, in the middle of the day. The sun is right there, fierce and blinding, close enough in cosmic terms to touch, and yet all around it, in every direction, the sky is black, not deep blue, not charcoal, black, total and seamless, in full daylight. Most people, hearing that for the first time, file it away as a curiosity. But let us slow down here, because hiding inside that blackness is one of the oldest and most stubborn questions in the history of science. A question so simple that a child can ask it, and so deep that it took humanity centuries to answer. Here is the question: why is the night sky dark at all? I know how that sounds. It feels like asking why water is wet. The night is dark because the sun went down. Surely that is the whole story. But stay with me, because the moment you think about it carefully, the obvious answer falls apart. Consider what astronomers, by the early 1800s, believed about the universe. They believed it was infinite and filled with stars, more or less evenly, going on forever. And if that were true, then a strange and airtight piece of logic takes over. If the universe is infinite and full of stars, then, no matter which direction you look, your line of sight must eventually land on the surface of a star. Every single direction. Think of standing in an endless forest. Nearby, you see individual trunks with gaps between them, but look far enough into the distance, and the gaps close. Every line of sight ends on wood. The forest becomes a solid wall of trees. An infinite universe of stars should work exactly the same way. Every point of the night sky, every tiny gap between the stars you can see, should be filled in by the light of stars farther away, and farther still, without end. The gaps should close. The whole sky, every night, should blaze like the surface of the sun, not sprinkled with stars, solid with them. Day and night would be indistinguishable, and life on earth would be impossible under a sky of fire. And yet, you have seen the night. It is dark, overwhelmingly, obviously dark, with a few thousand lonely points of light scattered across an ocean of black. That contradiction has a name. It is usually called Olbers' paradox, after Heinrich Wilhelm Olbers, a German physician and astronomer who described it clearly in 1823, though in fairness, and this is worth saying plainly, Olbers was not the first to notice it. Johannes Kepler had wrestled with a version of the problem 2 centuries earlier, in the early 1600s, and used it to argue that the universe of stars could not be infinite. The English astronomer Edward Harrison, who wrote what is widely considered the definitive history of this puzzle, a book called Darkness at Night, published in 1987, traced the question back through centuries of thinkers who saw it, worried about it, and could not solve it, because the darkness of the night sky is not a small detail. It is evidence. It is the universe telling you, every single night, that something about the simple picture is wrong. Either the universe is not infinite, or it is not eternal, or the light of distant stars is somehow prevented from reaching us. The dark sky is a message, written in the absence of light, and for hundreds of years nobody could read it. Some tried. One popular idea claimed that clouds of dust and gas between the stars simply blocked the distant light. It sounds reasonable, and there really is dust out there, as we will see later tonight. But as physicists eventually realized, that answer fails on its own terms. In an eternal universe, dust that constantly absorbs starlight would heat up century after century until it glowed as brightly as the stars themselves. The wall of fire would still be there. It would just be a wall of glowing dust. The paradox survived every easy answer thrown at it. And now comes my favorite part of this story, the part that feels almost too good to be true, except that it is documented and you can read it yourself. Among the first people anywhere to publish something close to the correct resolution was not a professional scientist at all. It was Edgar Allan Poe. Yes, that Edgar Allan Poe, the American master of the macabre, the author of The Raven and The Telltale Heart, a man whose entire body of work is, in a sense, about darkness. To understand what he did, it helps to know where he was standing when he did it. By the winter of 1848, Poe was near the end of a very hard road. His young wife Virginia had died the previous year. He was poor, unwell, and his literary fortunes had been rising and collapsing for 2 decades. And in that condition, rather than retreating into quiet, he turned his attention to the largest subject available to a human being. He announced a public lecture in New York on the nature of the universe itself. Accounts of that evening describe a stormy night and a small audience. A few dozen people at most, gathered to hear a famous author of horror stories deliver what was essentially a cosmology. He then expanded the lecture into a book-length work called Eureka, which he described as a prose poem, and asked to be judged as a poem rather than as science. Accounts of its publication suggest Poe hoped for an enormous printing and received a modest one. It was, by every commercial measure, a failure. Most of Eureka is speculation, and much of it is wrong by modern standards. But buried inside it is one astonishing passage where he confronts the riddle of the dark night sky directly. Poe reasoned that if the universe were endless and eternal, the sky would indeed be a continuous blaze of light. And then he offered a way out. The only way, he wrote, that we could understand the voids our telescopes find in the sky would be by supposing the distance of the invisible background so immense that no ray from it has yet been able to reach us at all. Let that sentence settle. Slowly, the way a stone settles through still water, because it is the answer, or at least the heart of it. Poe was suggesting that the universe might not be eternal, that it might have had a beginning, and that light, traveling at a finite speed, has simply not had enough time to arrive from the most distant regions. The sky is dark. In other words, not because the stars are not there, but because their light is still on its way, and some of it will never finish the journey. In 1848, this was pure intuition. Poe had no equations, no telescope data, no way to test it. The scientific establishment largely ignored Eureka, and Poe died the following year, in Baltimore, still known for stories about ravens and beating hearts rather than for cosmology. It would take physics the better part of a century to catch up with what he had guessed. But Edward Harrison, the historian of this problem, examined the record carefully and gave Poe real credit, describing him as the first to offer an essentially correct explanation for why the night sky is dark, while noting clearly that Poe reached it by intuition rather than by proof. There is something genuinely moving in that. A man in the worst year of his life, dismissed by the scientists of his age, standing in front of 60 people on a stormy night in New York, and being right about the shape of the universe. He is remembered as a poet of darkness. He deserves to be remembered as the man who read what the darkness was saying. And the message he decoded is one you can verify tonight, without any instrument at all. Just look at the dark between the stars. That dark is not emptiness. It is time. It is the visible edge of a universe that has not existed forever, which raises the question this whole chapter has been quietly building toward. If Poe was right, if the universe had a beginning, then when? How old is it? How far does the darkness go before it stops being distance and starts being the beginning of everything? Science now has real answers to those questions. Measured, tested, precise answers, and they are stranger and more beautiful than anything Poe ever imagined. Let us start with the number itself, because it is one of the great achievements of the human species, and it deserves to be said carefully. The universe is about 13.8 billion years old. That figure is not a guess and not a philosophical preference. It comes from multiple independent lines of evidence that all converge on nearly the same answer. The most precise measurement comes from a European Space Agency mission called Planck, a space telescope that spent years mapping the oldest light in the cosmos. In 2018, The Planck team published their final results, giving the age of the universe as 13.8 billion years, with an uncertainty of only a few tens of millions of years. In cosmic bookkeeping, that is astonishing precision. It is like knowing a person's age not just to the year, but nearly to the week, 13.8 billion years. And light travels at a fixed, finite speed, about 186,000 miles every second. Fast beyond imagining, but not infinite. Put those two facts together, and Poe's intuition becomes hard science. Light has only had 13.8 billion years to travel, which means there is a limit, a real, physical limit, to how far we can see. Beyond a certain distance, the light simply has not arrived yet. Astronomers call everything within that limit the observable universe, and the word observable is doing enormous work in that sentence, because it quietly admits that there is more, possibly vastly more, regions whose light has never reached us at all. This is the true reason the night sky is dark. The forest of stars is real, but the forest is young. The universe has a finite age, so light from indefinitely distant regions has not had the time it would need to arrive. Look between the stars, and your line of sight does not end on the surface of some impossibly distant sun. It runs out of universe before it runs out of darkness. Many of those dark gaps between the visible stars open, in principle, all the way toward the deepest history of everything. Picture that for a moment, gently, without needing to hold it tight. When you look at the black between two stars, you are looking down a corridor of time, toward a beginning older than the earth, older than the sun, older than every atom of iron in your blood. People pay fortunes to visit ancient places. You have the most ancient view there is, free, above your roof, on every clear night. But time is only half the answer. There is a second reason the sky is dark, and it emerged in the 1920s. In one of the great turning points in the history of thought, the universe is not sitting still. It is expanding. The idea arrived from two directions at once. In 1927, a Belgian priest and physicist named Georges Lemaitre published theoretical work showing that the equations of gravity naturally described an expanding universe. And he connected that idea to early measurements of galaxies. 2 years later, in 1929, the American astronomer Edwin Hubble, working at the Mount Wilson Observatory in California, published the observational evidence that settled it. Distant galaxies are moving away from us, and the farther away a galaxy is, the faster it recedes. Space itself is stretching, carrying the galaxies with it like raisins in a rising loaf of bread. A quiet Belgian theorist and a famous American observer, arriving at the same enormous truth from opposite sides, within 2 years of each other, and that stretching does something to light. As space expands, light traveling through it gets stretched too. Its waves grow longer, sliding from visible colors down into infrared and then radio, fading as they go. Astronomers call this redshift. The light of the most distant galaxies arrives at Earth, stretched, dimmed, and shifted so far that human eyes could never register it. So, even within the observable universe, expansion is quietly turning down the lights. That is the second reason the night is dark. Not only has the light of the farthest regions not arrived, much of what does arrive comes in worn thin. Then, In 1998, came a discovery that gave this story its modern shape. Two independent teams of astronomers, one led by Saul Perlmutter, the other by Brian Schmidt and Adam Rees, were studying distant exploding stars, expecting to measure how much the expansion of the universe was slowing down under gravity. Instead, both teams found the opposite. The expansion is speeding up. Some unknown component of reality that physicists now call dark energy, is pushing the universe apart faster and faster. The discovery was so unexpected and held up so well under scrutiny that Perlmutter, Schmidt, and Rees were awarded the Nobel Prize in Physics in 2011. What that acceleration means for the very distant future of the sky is a genuinely strange story, and it deserves its own chapter. So, I am going to save it. It is waiting for us later tonight, after we have travelled far enough to be ready for it. For now, keep just one honest, simple picture. The darkness of the night sky is not an accident and not a blank. It is made of two things. It is made of time, because the universe is young enough that light from the farthest reaches has not had time to cross to us. And it is made of stretching, because the space between us and the distant fires keeps growing, and the light crossing it arrives faded. The night sky is dark the way a shoreline is shaped, not by nothing, by enormous forces, working patiently for billions of years. And here is the gentlest part, the part worth resting on. Nothing about this darkness is owed to you or asked of you. The stars you can see from your window are all nearby, all inside our own galaxy, all bound to us by gravity, and they will look the same for longer than your species will exist. The deep darkness beyond them holds the history of everything, and it holds that history whether anyone is watching or not. Tonight, someone is. You are. That is already more than the universe requires. So we have answered the child's question. The sky is dark because the universe began, and because it grows. But notice that everything so far has been reasoning, history, and measurement. We have not actually gone anywhere yet. The blackness, described at the start of our last chapter, the black sky of space in full daylight, is still waiting up there, just past the top of the air. It is time to stop describing it and go stand in it. And this time, we are not going alone. We are going with the people who were actually there, the handful of human beings who have floated in that blackness, looked around, and come home to tell us what it was like. Here is a simple question that sounds like a riddle. Why is the sky blue? You have known the answer was out there since you were a child, even if nobody ever told you what it was. And it matters tonight, because hidden inside that answer is the reason space is black. And once you see it, you will never picture the sky the same way again. Sunlight looks white, but it is actually a mixture of every color at once. When that light plunges into our atmosphere, it starts colliding with the molecules of the air itself. Countless trillions of tiny particles of nitrogen and oxygen, each collision scatters a little light sideways, and the physics of that scattering, worked out in the late 1800s by the British physicist Lord Rayleigh, has a strong preference. Short blue wavelengths scatter far more easily than long red ones. So as sunlight pours down through the air, blue light gets bounced around the entire dome of the sky, ricocheting from molecule to molecule until it comes at you from every direction overhead. The sky is blue because the air itself is glowing with scattered sunlight. Now, take the air away. No molecules, no collision, no scattering, no glow. Sunlight in empty space travels in perfectly straight lines from the sun to whatever it happens to hit. Nothing spreads it across the sky, because there is no sky. There is only the sun in one direction, blindingly bright, and in every other direction, nothing at all. Blackness, right beside brilliance. Noon and midnight occupying the same view. The blue sky, in other words, is not space. It is a thin, bright ceiling of scattered light, a kind of lampshade wrapped around the planet. And it is astonishingly thin. If you could drive your car straight up, you would pass the altitude where most of that scattering happens in well under an hour. Your whole life has been lived at the bottom of a shallow, glowing sea, and the true blackness begins just past the surface. Do not take my word for it. Ask the people who went. Only a few hundred human beings have ever left the atmosphere, and many of them have described the contrast between brilliant sunlight and that black sky in memorable terms. In July of 1969, when Buzz Aldrin stepped onto the moon during the Apollo 11 mission, he stood in full daylight. The sun was up. The ground around him was brightly lit. Grey dust stretching to the horizon, and above that sunlit ground, the sky was utterly black, because the moon has no meaningful atmosphere, no lamp shadow, no glowing sea, surveying that sunlit grey landscape beneath its black sky. Aldrin reached for words and produced a phrase that has become famous, calling the scene magnificent desolation. On the moon, day and night share the sky at the same time. His crewmate, Michael Collins, may have come to know that blackness even more intimately. While Aldrin and Neil Armstrong walked the surface, Collins orbited the moon alone in the command module. Each time his spacecraft swung around the far side, he lost radio contact with Earth, lost sight of his home planet, and passed through a solitude no human being had ever experienced before. In his memoir, Carrying the Fire, published in 1974, Collins wrote about that solitude honestly, and what he wrote surprises people. He described a powerful awareness of being separated from every other living person by the body of the moon itself, and what he described feeling amounted not to fear or loneliness, but to something closer to calm, focused exaltation. He was, by his own account, content back there in the dark, alone on the far side of another world, with the deepest night in human experience outside his window. A man found it peaceful. That is worth keeping tonight. It is the first testimony in our story from someone who actually went, and it is a good one. Now, if you have ever looked closely at the photographs from those missions, you may have noticed something that puzzles many people. The lunar sky in the pictures is black, and yet it shows no stars. None. Some people have pointed at that empty blackness and called the whole thing fake. So let us take a minute and give that blackness the honest explanation it deserves. Because the truth is more interesting than the suspicion. The cameras on the moon were set for daylight. The sunlit surface and the white spacesuits were dazzlingly bright. So the exposures were fast and narrow, exactly like taking a photo of a sunny beach. At those settings, faint points of starlight simply do not register on the film. You can prove this to yourself tonight with any phone camera. Photograph a streetlight, and the dark sky around it comes out empty. Even if stars are up there, the astronauts themselves reported the same thing with their own eyes. Standing on the bright surface, their pupils contracted for daylight. They could see almost no stars in that black sky. Only by shielding their view from the glare could they begin to pick stars out. The stars were there the whole time. Daylight eyes cannot receive them. I love that detail, because it repeats a lesson this night keeps teaching. Darkness is not simply what exists around you. It is a negotiation between the light that is present and the instrument that is looking. The lunar sky was black and full of stars at the same moment, and which one you got depended entirely on how you looked. So this is the reality just past our lampshade of air. Permanent blackness, indifferent to the time of day, with the sun hanging in it like a lamp in an unlit warehouse. Yet notice something. In every scene we have visited so far, the sun itself was present, blazing away, even in the blackest sky. There was always that one overwhelming light, which leads to the next natural question. What happens in the places the sunlight cannot reach at all? Where is the nearest true shadow? The nearest region of space where the sun's light is actually blocked? The answer is closer than you think. You are inside it right now. It rises in the east every evening, and you have watched it your whole life without ever being introduced to it. Every object standing in sunlight casts a shadow, a fence post, a mountain, you, and so does the earth. It sounds obvious the moment it is said, but very few people ever actually picture it. Our planet, 8,000 miles wide, is standing in the light of the sun, and behind it, on the side turned away, it casts an enormous cone of darkness out into space. That cone is real. It has a measurable size and shape. It tapers to a point roughly 1.4 million kilometers behind the Earth, close to 900,000 miles, more than 3 times farther away than the Moon. A tower of night, taller than 100 Earths stacked on top of each other, sweeping around the sun with us, like the tail of a compass needle, always pointing away from the light. And this is the part I find quietly wonderful. Night itself, the ordinary night you live through, is simply what it feels like to stand inside that structure. Every evening, the spot of Earth you live on rotates into the cone, and every morning it rotates back out. Nightfall is not the sky doing something. It is you, personally, riding the turning planet into the planet's own shadow. You have spent roughly half your life inside this tower of darkness without ever being told its name. You are inside it at this very moment. And notice, it has never once harmed you. It arrives on schedule. It leaves on schedule. And it has kept every appointment for 4.5 billion years. Few things in your life are as reliable as this shadow. Let that reliability hold you for a moment. The way a familiar blanket does. You can even see it. This is one of my favorite pieces of sky knowledge, because it turns an ordinary evening into an event. On any clear evening, just after sunset, turn your back on the sunset and look at the opposite horizon, the eastern one. Low along that horizon, you will see a band of dusky blue-grey, darker than the sky above it, slowly rising as the minutes pass. That band is the shadow of the Earth itself, projected onto the atmosphere, climbing up the eastern sky as the sun sinks lower in the west. Just above it often glows a soft band of pink, a fringe of late sunlight passing over the shadow's edge, which skywatchers have long called the belt of Venus. Most people have seen this 100 times and assumed it was just dusk being pretty. It is your planet's shadow, and now that you know, you will spot it for the rest of your life. Sometimes, the moon flies into it. The moon orbits the Earth at an average distance of about 240,000 miles, well inside the reach of that 900,000-mile cone. Usually, its tilted orbit carries it above or below the shadow, but a few times a year, the alignment comes out exact, and the full moon glides into the cone of night. We call it a lunar eclipse, and for an hour or more, the brightest natural light of our nights is switched off in slow motion while the whole night side of Earth watches. You would expect the moon to simply vanish, swallowed whole. It does something stranger. It turns red, a deep, dim, coppery red, hanging in the sky like an ember. And the reason is one of the most beautiful facts in astronomy. The Earth's atmosphere, that same thin glowing sea from our last chapter, bends a little sunlight around the edges of the planet and into the shadow. On its way through, the air scatters away the blue light, exactly as it does at every sunset, and lets the red pass. What reaches the eclipsed moon is the combined light of every sunrise and every sunset happening on Earth at that moment. All of them at once, projected across 250,000 miles onto the lunar surface. If you stood on the moon during a lunar eclipse and looked up, you would see the black disk of the Earth surrounded by a thin, glowing ring of sunset red. The shadow of our world is trimmed with fire. So the Earth's shadow is not just an absence, it is a place, with a shape, a color at its edges, and visitors. And that raises a practical question that modern astronomy has had to answer. If you were building the most sensitive telescope in history, an instrument designed to detect the faintest whispers of heat from the beginning of time, would this shadow not be the perfect home for it? A ready-made refuge from the sun. Astronomers thought about exactly this. There is a special location in space, worked out mathematically in the 1700s by the mathematician Joseph Louis Lagrange, called the second Lagrange point, or L2 for short. It sits about 1.5 million kilometers behind the Earth, directly along the Sun-Earth line, precisely the direction the shadow points. At that spot, the combined gravity of the Sun and Earth lets a spacecraft circle the Sun in lockstep with us, keeping the Sun and Earth forever on the same side of the sky. It is the natural address for a telescope that needs to hide from both. And notice the numbers. The shadow cone ends at about 1.4 million kilometers. L2 sits at 1.5 million. The great cone of night falls just short. Nature's refuge stops one step before the perfect parking spot. So when NASA and its partners sent the James Webb Space Telescope to L2 in December of 2021, they did not park it in Earth's shadow. They could not. A spacecraft fully inside the shadow would also lose its solar power, starving in the very darkness it came for. Instead, Webb loops around the L2 point in a wide, slow orbit, staying in constant sunlight. And it does something deeply satisfying. Given everything tonight has shown us, it brings its own shadow. Webb carries a sunshield the size of a tennis court, 5 silvery layers of foil, and it keeps that shield aimed at the sun, the Earth, and the moon all at once. Behind the shield, the telescope rests in a manufactured night hundreds of degrees below zero, cold enough to sense heat that has traveled for over 13 billion years. Humanity needed a darkness deeper and more reliable than the shadow of its own planet. So we built one, and it works. There is the lesson of this chapter. Stated as plainly as I can, darkness is not the enemy of seeing. Darkness is the requirement for it. The deepest views of the universe ever achieved come from an artificial patch of night, engineered with more care than most sources of light. But Webb's little pocket of cold lasts only as long as its shield holds the sun away. Nature does this on a grander scale, without any engineering at all. There is a world right beside us where the shadow is not a cone you pass through in hours, but a season you must endure. A place where night falls and then simply stays, for 2 full weeks at a time, and where the darkness brings a cold that has ended many missions and defeated many machines that were never built to survive it. We have been circling that world all night. It is time to land on it. The moon is the only other world human beings have ever stood on, and every one of those visits shared a detail that most people never notice. Every crewed landing, all 6 of them, from Apollo 11 in July of 1969 to Apollo 17 in December of 1972, happened during lunar daytime. Not one astronaut ever stayed to see the sun go down. That was not an accident of scheduling. It was survival, because night on the moon is not like night on Earth. And the difference begins with a single fact about how the moon turns. The Earth spins once every 24 hours. So no matter where you stand, darkness is a visitor that leaves by morning. The moon rotates far more slowly, turning once in about a month, the same time it takes to circle the Earth, which means a single day-night cycle on the moon lasts about 29.5 Earth days. Sunrise to sunset alone takes nearly 15 days, and when the sun finally sets, it stays down for roughly 2 more weeks. 14 days of unbroken darkness before the next dawn. Now add what that darkness does to the temperature. On Earth, our blanket of air holds the day's warmth through the night, spreading heat from the sunlit side of the planet to the dark side. The moon has no such blanket. When the sun sets, the heat of the 2-week day simply pours off into space, and nothing replaces it. In the full lunar daytime near the equator, surface temperatures can soar past 200 degrees Fahrenheit, hot enough to boil water. Then night falls, and the same ground plunges to somewhere between about 200 and 280 degrees below 0 Fahrenheit, depending on where you are standing and how the terrain holds heat. A swing of roughly 400 degrees between noon and midnight, on the same patch of dust, with no weather and no wind in between. For a machine full of delicate electronics, the lunar night is one of the harshest tests in the inner solar system. And what makes it harsh is not radiation or impact or anything exotic. It is simply darkness, held long enough to become profound cold. Machines have been meeting that darkness for 60 years. And the meetings rarely go well. The pattern was set at the very beginning. Surveyor 1, the first American spacecraft to soft land on the moon, touched down in June of 1966 and worked beautifully through the lunar day. Then night came. Engineers put the lander to sleep and hoped it actually survived that first night and answered when dawn arrived, which was a genuine triumph. But each following night placed more stress on a machine that had never been designed for this. And within months, its transmissions ended for good. That story has repeated, with variations, ever since. In recent years, a new generation of landers has gone to the moon, and the 2-week night remains the great filter. India's Chandrayaan-3 mission made history in August of 2023 by landing near the lunar South Polar region. And its Vikram lander and Pragyan rover completed their planned mission through one lunar day, a genuine national triumph. When night approached, the machines were set to sleep with a hope, stated openly by the Indian Space Agency, that they might wake at sunrise. Dawn came 2 weeks later. Mission Control listened. The lander never spoke again. The extreme cold of the lunar night was the most obvious suspect, though without renewed contact, the exact cause of the silence could never be confirmed. To be fair to the machines, many of them, including Vikram, were only ever designed for a single lunar day. So, surviving the night was a hoped-for bonus rather than a promise. But that is precisely the point. Engineers plan around this darkness the way sailors plan around a reef. Japan's Slim lander, which touched down in January of 2024, surprised its own engineers by waking up after lunar nights it was never designed to survive. And that survival was reported as genuine news, precisely because nobody expected it. On the moon, a machine that lives through the night makes headlines. That is how hard the darkness is. Some missions manage it the only way physics allows, by bringing their own warmth. China's Chang'e 4 lander and its Yutu-2 rover, which in January of 2019 made the first landing in history on the far side of the moon, carried small radioactive heat sources to keep their vital parts warm through the darkness. And they went on to operate for years, sleeping through each night and waking at each dawn. The lesson is the same one Webb taught us at L2. Seen from the other side. Out there, you do not simply endure light and darkness on their terms. You must engineer your own, or live by the schedule of someone else's. And yet the strangest part of the moon's darkness is not the night that lasts 2 weeks. It is the night that has lasted, in some places, for billions of years. Near the moon's poles, the geometry of light becomes extreme. The moon's axis is barely tilted, only about 1.5 degrees. So at the poles, the sun never climbs more than a whisker above the horizon. It circles the sky sideways, skimming the rim of the world. And that means the floors of deep craters near the poles are places sunlight cannot reach. Not at noon, not in any season, not ever. The crater walls block the low, sideways sun completely, and the floors below sit in what scientists call permanently shadowed regions. NASA's Lunar Reconnaissance Orbiter has mapped these regions in detail, and researchers believe some of these crater floors, in basins like Shackleton Crater near the South Pole, have not felt direct sunlight for billions of years. Stay with that number for a moment, because it is easy to let it slide past. Billions of years. When the last light fell on those crater floors, there was no life on land anywhere on Earth. No trees, no animals, possibly nothing more complicated than single cells in shallow water. Everything that has ever happened in the story of life, every forest, every ocean full of fish, every dinosaur, every human being who ever lived, and everyone you have ever known, has happened entirely within the span of that one unbroken lunar night. And it is still going on. It is going on right now, 250,000 miles above you, unchanged, while you lie in a warm room, deciding whether to fall asleep. Those floors are also among the coldest places ever measured near the Earth. Instruments on the Lunar Reconnaissance Orbiter have recorded temperatures in some of these shadowed craters dropping below -400 degrees Fahrenheit, colder than the surface of Pluto, colder than almost anywhere else humanity has ever pointed a thermometer. And here is the turn. The reason these black pits are now some of the most wanted real estate in space. Coal that deep is a preservative. Any water that ever arrived at the moon, delivered over the ages by comets and asteroids, would vanish quickly in the boiling lunar day. But a water molecule that drifted into one of these eternally dark craters would freeze and stay frozen, trapped in a cold so profound that it could survive for billions of years. And the evidence says this actually happened. In 2009, NASA deliberately crashed a spent rocket stage into the shadowed crater Cabeus near the lunar south pole, and a following spacecraft, called L-Cross, flew through the plume of debris and detected significant amounts of water ice mixed into that ancient dark soil. Later observations by multiple missions have supported the picture. The permanently shadowed craters hold water, real, frozen, usable water, potentially enough to matter enormously for any future human presence on the moon. Let that settle, because it may be the purest example yet of the idea this whole night keeps returning to. The most forbidding darkness on the moon, the coldest and oldest night in our neighborhood, turns out to be the treasury. The 2-week night defeats machines, but the permanent night keeps the water. If people ever live on the moon for good, they will very likely live there because of what the darkness protected. The darkness is not the obstacle to that future. It is the reason that future is possible. So the moon has shown us darkness as duration, night stretched until it becomes an ordeal, and darkness as sanctuary, night deep enough to guard treasure. But in every scene so far, one assumption has quietly held. Somewhere nearby, the sun was still the sun, blinding, dominant, the unquestioned source of day. That assumption has a range. Travel far enough from the sun, and daylight itself begins to fail. Not switch off, but fade, world by world, like a lamp receding down an endless hallway. And there is a wonderful, simple way to feel exactly how that fading goes. One that ends with a discovery about your own evenings that I think will genuinely delight you. That is where we are headed now, out into the space between the planets, to watch the daylight dim by degrees. Sunlight feels infinite. Stand outside on a July afternoon in Texas or in Spain, and the idea that daylight is a limited local resource, something that runs thin with distance, seems absurd, but it is true, and the rule that governs it is simple enough to hold in one hand. Light spreads out, move twice as far from the sun, and its light is spread over 4 times the area, so you receive 1/4 the brightness. Move 10 times farther, and you receive 1/100th. Physicists call this the inverse square law, and it has been understood since the days of Kepler and Newton. It means daylight is not a constant of nature. It is a dividend paid by proximity, and the solar system pays it out on a steeply declining scale. Let us actually take the walk and watch the payments shrink. There is no hurry and nothing to memorize. Let each world simply pass by, the way stations pass a slow train at night. Start at Mars. The next world out. About 1.5 times our distance from the Sun. Daylight, there is a little less than half as strong as Earth's. Noon on Mars still looks like day. But photographs from NASA's rovers show a landscape lit like a late autumn afternoon. Everything slightly dim, slightly cold in tone. An astronaut on Mars would not need a flashlight at noon, but they would feel, in some quiet bodily way, that the Sun had lost a step. Keep going. Out to Jupiter. About 5 times our distance. The math now bites hard. 5 times. The distance means 25 times less light. Daylight on Jupiter is about 4% of what you are used to. That is no longer afternoon. That is deep, heavy overcast. The gloom just before a storm. As a permanent condition. The Sun still looks like the Sun. A distinct blazing disk. But it is a small one. And the world it lights is a dim world. At Saturn, nearly 10 times our distance. Sunlight is down to about 1%. And here, I have to stop and point at something. Because you have seen Saturn, you have seen the photographs from the Cassini spacecraft, which orbited Saturn from 2004 to 2017. The golden globe, the luminous rings. Those images feel sunlit, radiant, warm. Understand what you were actually seeing. That gleaming portrait was painted with roughly 1% of the light in your kitchen at breakfast. The cameras drank in that faint light with patient exposures, the way your own eyes open up in a dark room. Saturn lives in permanent twilight and manages to look like jewelry, even at 1%. Sunlight is still an artist. Now go all the way out. Pluto orbits, on average, close to 40 times the Earth's distance from the Sun. 40 times the distance means roughly 1,600 times less light. Noon on Pluto receives about 1/1600th of the sunlight you receive on Earth, and you would be forgiven for assuming that must be essentially night. Almost everyone assumes that. This is where the story turns. And it turns because of a fact about you, your eyes. As we learned in the caves of our first chapter, are instruments of absurd sensitivity, built for a world of true darkness. 1/1600th of daylight sounds like nothing, but the human eye handles ranges like that without complaint. Noon on Pluto is not blackness. It is dusk. Specifically, it is about the light level on Earth shortly after sunset. That soft blue hour when the sun is down but the sky still glows. When you can walk easily, read a book with mild effort, and see the world in full shape and muted color. Astronomers at NASA worked this out precisely, and they built something charming with the answer. It is a small online tool called Pluto Time, published on NASA's own website around the time the New Horizons spacecraft flew past Pluto in July of 2015. Enter your location. Tells you the exact minute on any clear evening when the fading light around you matches high noon on Pluto. Twice a day, at dusk and at dawn, your neighborhood is lit exactly as brightly as the surface of the most famous world in the outer solar system. I genuinely love that. And here is why it belongs in this night's story. You have been to Pluto's noon. You were there this very evening. If the sky was clear, in the minutes after the sun went down, the unimaginable dimness of the outer solar system is not unimaginable at all. It is a familiar hour of your ordinary day, relocated 3 billion miles from home. When New Horizons sent back its images of Pluto's ice mountains and frozen plains, it was photographing a landscape lit like your street at twilight. And the sun in Pluto's sky, while far too small to show a disk to the naked eye, still shines there, hundreds of times brighter than the full moon does here, bright enough to cast shadows, bright enough to glitter on the nitrogen ice. The sun, even at the edge of the planetary system, refuses to become just another star. So, the next time you stand outside at dusk, you can try this. Let your breathing slow to match the fading of the light, and remind yourself that this exact softness, this exact blue-gray hush, is what the brightest hour of the day looks like on a world 3 billion miles away. Somewhere out there, this is noon. Your evening calm is another world's high daylight. There are few gentler thoughts to carry towards sleep. But notice the direction this walk has been heading. Because the trend does not stop at Pluto, day has been dimming by degrees the whole way out. Full daylight at Earth, autumn light at Mars, storm gloom at Jupiter, twilight at Saturn, and dusk at Pluto. Every step outward has moved us later into the evening of the solar system. And the solar system does not end at Pluto. The walk keeps going, into the realm of the comets, out where the sun's brightness keeps falling by that same patient square of the distance. Somewhere out there, on that long road, the last trace of day runs out entirely. Somewhere out there is the place where the sun finally stops being a source of daylight and becomes merely the brightest star in a black sky. A bright point among points, a former day. We know a spacecraft that has made that journey, farther than any machine in human history. And we will ride along with it soon. Because in 1990, at the request of one particular astronomer with a poet's instinct, it turned its camera around one last time and looked back at everything it was leaving. Before we join it, though, there is one more kind of darkness waiting between here and there. Not the smooth fading of distance, but something stranger. Actual clouds of blackness, hanging among the stars, so dark and so sharply outlined that the astronomer who first swept the northern sky believed he had found openings punched clean through the universe. Those clouds are next. And the story of the man who finally understood them is one of the finest in all of astronomy. It begins with a 9-year-old boy in Tennessee, holding a camera pointed at the sun. In the 1780s, the astronomer William Herschel was doing something no one had ever done before. Night after night, from his garden in England, he was sweeping the entire sky with the largest telescopes in the world. Telescopes he had built with his own hands, counting stars in every direction, trying to map the actual shape of the heavens. His sister Caroline sat beside him through the cold hours, recording everything he called out. Together, they catalogued thousands of star clusters and glowing clouds, and they knew the sky more intimately than any two people alive. Which is why what happened one night in 1785 is worth pausing on, sweeping through the constellation Scorpius, a rich, crowded region blazing with stars. Herschel came to a patch where the stars simply stopped, not thinned out, stopped, a dark opening in the middle of the crowded field, with stars all around its edges and nothing inside. Accounts of that night, passed down through astronomical tradition, record his astonishment in words he is said to have exclaimed aloud, "Here truly is a hole in the sky." and you can understand why he would say it. Everything Herschel knew told him that stars filled the heavens in every direction. So a black gap this sharp, this empty, could only mean one thing to him. He believed he was looking through a genuine tunnel of nothingness, a canyon where the stars were absent, letting him see clean through the star system and out the far side into the void beyond. It was a completely reasonable conclusion. It was also wrong. And the truth is stranger and more wonderful, though it took more than a century to arrive. The man who finally proved it was an American, and his life is one of my favorite stories in the history of science, because nothing about its beginning suggests where it would end. Edward Emerson Barnard was born in Nashville, Tennessee, in 1857, into severe poverty. His father died before he was born. His mother raised him through the hardest years the American South had known, and he had almost no formal schooling of any kind. At age 9, to help feed the family, he went to work in a photography studio, and the job he was given was one of the most tedious jobs imaginable. The studio used a large solar camera that had to be kept aimed at the sun, and the boy's task was to stand there, hour after hour, day after day, keeping the machine pointed at the light. It was dull, aching, endless work for a child, and it quietly gave him two things that would change the history of astronomy. It gave him photography, and it gave him a patience with light that almost no one else on Earth possessed. Barnard fell in love with the night sky as a teenager, acquired a small telescope, and taught himself the stars from a Tennessee rooftop. He began hunting comets as a young man, at a time when a wealthy patron was offering a cash prize for each new comet discovered by an American, and Barnard found enough of them that the prize money, according to the story he told for the rest of his life, helped pay for a small house for his family. The neighbors called it the Comet House. From there, on talent and persistence alone, he rose to become one of the greatest observational astronomers who ever lived, holding positions at the Lick Observatory in California and then at Yerkes Observatory in Wisconsin. And, late in his career, he turned everything he had toward those mysterious dark patches, the holes in the sky. He photographed them with long, patient exposures on cold country nights, hundreds of plates over many years, and he studied their shapes with the eye of a man who had spent his entire life, from age 9 onward, reading what light does on a photograph. The shapes told him the secret. The dark patches had structure. They had wisps and tendrils and soft edges that curled exactly the way smoke curls. Holes do not have tendrils. Tunnels through the stars would not trail delicate streamers along their borders. In a paper published in 1919 in the Astrophysical Journal, Barnard laid out his catalogue of these dark markings and the conclusion he had been carefully building toward for years. These were not holes at all. They were objects, vast clouds of something dark, hanging in space between us and the stars, blocking the light from behind. The stars were still there, in their countless multitudes. Something enormous and black was standing in front of them. Herschel had found a hole in the sky. Barnard, the boy who once held a camera steady against the sun, proved the hole was a thing. We now know exactly what these things are. They are called dark nebulae, and they are clouds of gas and dust, mostly hydrogen, laced with microscopic grains of carbon and silicate, the same sort of stuff as fine soot and sand. The individual grains are smaller than particles of smoke, and the clouds are almost unimaginably sparse, far emptier than any vacuum chamber on Earth. But they are also enormous, often many light years across, and light, trying to cross trillions of miles of even the thinnest soot, does not make it through invisible wavelengths. The cloud absorbs and scatters the starlight until, to our eyes, nothing is left. Blackness, cut out of the sky in the shape of the cloud. Some of them you can see with your naked eye, and people have been seeing them for as long as people have looked up. Stretching through the summer, Milky Way is a long dark channel called the Great Rift, which splits the glowing band of our galaxy in two. In the southern sky hangs a black patch called the coal sack, so prominent against the bright Milky Way that it appears in the sky knowledge of cultures across the southern hemisphere. And this detail I find genuinely moving, where European tradition made constellations by connecting the bright stars. Aboriginal Australian traditions, belonging to some of the oldest continuous cultures on Earth, also built constellations from the dark clouds themselves. In one widespread tradition, the coal sack forms the head of a great celestial emu, whose dark body stretches along the rift in the Milky Way. They read the blackness as a shape, as a presence. Thousands of years before Barnard proved that this is precisely what it is. The darkness was never nothing. Some people always knew, but the deepest surprise about these clouds is not what they are, it is what they do. Because when astronomers finally developed instruments that could peer inside the dark nebulae, infrared telescopes that sense heat, seeing through the dust, somewhat the way your ear hears through a wall, they found the clouds were neither empty nor idle. Deep inside the blackest of them, matter is quietly falling together. The cold, the dark, and the density work as partners, letting gravity gather gas into clumps, and the clumps into denser cores. And in those hidden cores, temperatures eventually climb until hydrogen ignites. Stars. The dark clouds are making stars. The blackest objects in the night sky are the birthplaces of the very lights that fill it. Astronomers studying small, especially dense dark clouds called Bok globules, named for the astronomer Bart Bok, who championed their study in the 1940s, have confirmed infant stars forming inside many of them. The famous pillars of creation, photographed by the Hubble Space Telescope in 1995 and again in far greater detail by the Webb Telescope in 2022, are exactly this: towers of dark dust, light years tall, with newborn stars kindling inside them. Our own sun, 4.5 billion years ago, almost certainly ignited inside just such a cloud. The daylight on your face this afternoon began long ago, in a place like the coal sack. You are, in the most literal sense available to science, something that came out of the dark. So let the image of those clouds drift with you for a moment, not as black holes torn in the sky, but as what they actually are: slow, cold, silent nurseries, doing their work over millions of unhurried years, in no rush whatsoever, with new suns growing warm at their centers the way a thought grows warm at the center of a long rest. Barnard, who died in 1923, proved the darkness was real and solid and present. He never learned it was a cradle. That part of the story was left for us, and, with it, a promise from the last chapter comes due. We have walked the fading daylight out past Pluto, and we left a spacecraft waiting for us there. At the edge of everything, the most distant machine our species has ever made. It is time to catch up with it, and to see what became of the sun from out where the sun is no longer the day. On Valentine's Day of 1990, that spacecraft turned around and took one last photograph of home. What it saw in that frame, and what it flies through tonight, is where our journey goes next. Voyager 1 left Earth on September 5th, 1977, from Cape Canaveral, Florida. If you are an American of a certain age, that means it launched into the world of your childhood, a world of station wagons and rotary phones, and it has been traveling away from you without a single day of rest ever since. Its mission was the planets through the late 70s and 80s. Voyager 1 and its twin, Voyager 2, swept past Jupiter and Saturn and sent home the first close portraits of those worlds. Images that redrew the textbooks. And when the planetary work was done, the spacecraft kept going, because there is no way to stop. They are falling outward forever. Today, Voyager 1 is the most distant human-made object in existence. More than 15 billion miles from the Sun, over 160 times the Earth's distance, still transmitting. Its faint signal taking nearly a full day to reach us even at the speed of light. But the moment that belongs to tonight happened on February 14th, 1990, and it happened because one man insisted. The astronomer Carl Sagan had served on the Voyager imaging team from the beginning, and for years he had been urging NASA to try something with no scientific justification whatsoever. He wanted Voyager 1, on its way out of the planetary system, to turn its cameras backward and photograph the Earth from that immense distance. There was resistance, and the resistance was reasonable. Pointing the camera back toward the Sun risked damaging its sensors, and the picture would show almost nothing. Earth, from about 4 billion miles away, would be less than a single pixel. What was the point? Sagan's answer, innocence, was that the point was the almost nothing. In 1990, with the cameras about to be shut down forever to save power, NASA agreed. Voyager 1 turned and took a final family portrait of the solar system. 60 frames, catching 6 planets as faint dots scattered across the black. In one of those frames, caught by chance inside a stray ray of scattered sunlight in the camera optics, there is a pale, small point, less than a pixel. That point is the Earth. Everyone you have ever loved was inside it when the shutter fired. Sagan later reflected on that image in his 1994 book, which he titled Pale Blue Dot, and those reflections have become some of the most quoted words in the history of science. So I will not recite what you may already know. I want to add, instead, the observation that belongs to this night in particular. Look at where the Earth sits in that photograph. It is a mote of dust suspended in blackness. The picture is almost entirely darkness. That is the true portrait of our situation, taken not by a philosopher, but by a machine reporting facts. Everything bright in our lives occupies less than 1 pixel. The rest of the frame, the overwhelming rest, is the dark this whole night has been about. And notice something people rarely say out loud about that image. The darkness in it does not menace the dot. It simply surrounds it, silent and neutral. The way the ocean surrounds a small boat that is doing perfectly well. Those were the last pictures Voyager ever took. The cameras were switched off soon after. exactly as planned, to save precious power for the instruments that could still do science in the dark. So the title of this chapter is Honest in a Way Worth Keeping. What Voyager saw, looking back, it saw once, on that February day, and never again. Its eyes have been closed for over 3 decades now. It flies on regardless, feeling its way through the dark with other senses, measuring particles and magnetic fields. Like a traveler walking a long road at night with a lantern that shines on everything except the road behind. Now ride along with it for a moment, because its situation out there, tonight, as you lie in bed, is worth feeling from the inside. From Voyager 1's position, more than 15 billion miles out, the Sun has undergone the final demotion that our walk through the planets was pointing toward. It shows no disk to the naked eye anymore. It is a point, still the brightest point in the sky by a wide margin. And this is worth getting exactly right. So, let me be careful with it. Run the honest arithmetic of the inverse square law across 160 times the Earth's distance, and the Sun from out there shines with roughly the brightness of a dozen or so full moons, gathered into a single brilliant star, bright enough to cast unmistakable shadows across the spacecraft's hull, not bright enough, ever again, to make anything like day. The spacecraft flies through a permanent, star-filled night, and the Sun behind it is now simply the first among the stars, the one marking the way home. In August of 2012, instruments aboard Voyager 1 detected a profound change in its surroundings, and after careful analysis, NASA scientists announced that the spacecraft had crossed a boundary called the heliopause. This is the edge of the Sun's own atmosphere of charged particles, the great bubble the Sun inflates around itself. And beyond it, the environment is dominated by the thin gas of interstellar space, the medium between the stars. Voyager 1 became the first human-made object in interstellar space, and Voyager 2 joined it in 2018. Let me be precise here. As always, this does not mean Voyager left the solar system. The Sun's gravity reaches vastly farther, holding comets in orbits thousands of times more distant. And by that definition, Voyager will remain inside the solar system for tens of thousands of years yet. What Voyager left was the Sun's weather. It flies now in the quiet between the stars, where the particles brushing its hull last streamed from suns other than ours. The machine itself is dying, slowly and gracefully. Its power source, a small generator running on decaying plutonium, produces a little less electricity each year. Engineers at NASA's Jet Propulsion Laboratory have spent the last decade performing a long, gentle triage, switching off instrument after instrument, heater after heater, keeping the most vital systems alive on a shrinking budget of watts. The people doing this work speak of the spacecraft the way one speaks of an aging relative, with tenderness and pride. Sometime in the coming years, the power will drop below what the transmitter needs, and Voyager 1 will fall silent. And then comes the part I find impossible to hold in my mind without a kind of awe. The silence will change nothing about the journey. Voyager does not need power to keep going. It coasts, frictionless, through near vacuum, at over 38,000 miles per hour, and it will simply continue. In about 40,000 years, NASA calculates it will pass within about 1.5 light-years of a small star called Gliese 445. It will almost certainly still be recognizable then. Out there, there is no rust, no rain, no wind, none of the ordinary erosion that dissolves everything we build on Earth. Though the deep dark has its own slow tolls, cosmic radiation and the occasional grain of drifting dust, working on timescales almost too long to speak about. Bolted to the spacecraft's side is the golden record, carrying the sounds of surf and birdsong and greetings in 55 languages, chosen by a committee Sagan led in 1977. It was designed, deliberately, as a message for deep time, engraved in gold-plated copper for exactly that reason. How long it would truly remain readable, across hundreds of millions or billions of years, is necessarily speculative, and no honest person can promise a number. What can be said is simpler and, I think, more beautiful. Nothing else we have ever made has a better chance at that kind of endurance. No pyramid, no cathedral, no vault. The gentlest archive our species has ever found is the darkness between the stars, and we have already placed 2 small machines in its keeping. So hold the full picture of where we have arrived, and let it be a calm one, because it is. Daylight is a local arrangement, and Voyager has outlived it. The sun, from out there, is one bright star among thousands, and the night Voyager flies through is permanent, still, and preserving. The first ambassador of our species is not being swallowed by the darkness. It is being kept by it, everything so far. Though every crater and cloud and spacecraft has been our own neighborhood, the moon next door, the planets down the street, one brave machine at the edge of the property. The universe has scales of darkness beyond all of this. So far beyond that, they required entirely new kinds of measurement to reach, because it turns out that the question every child eventually asks at a window, just how dark is space? Really, all of it, added up, is a question professional astronomers were still working to settle within the last few years. And the answer arrived from an unexpected messenger, not Voyager, whose eyes are closed, but its successor on the long road out, a younger spacecraft with its cameras still open, flying tonight through the darkest observing site any camera of ours has ever reached. Here is the question, stated the way a child would state it, pressed against a window at bedtime. If you added up all the light in the universe, every star, every galaxy, all of it shining at once, how bright would it be? Or, turned around, how dark is space? Really, once you get away from all the lamps, what I love about this question is that it is not childish at all. It is one of the most fundamental measurements in cosmology. It has a formal scientific name, the cosmic optical background, and the truly delightful part is this. Astronomers were still refining the answer in the 2020s, not in some ancient era of brass telescopes. Within the last few years, the total darkness of the universe was, until very recently, an open measurement, and the reason it stayed open so long is a problem you already understand, because this whole night has been preparing you for it. The problem is that we live inside a lampshade. Remember the lesson of the blue sky. The daytime sky is not space. It is sunlight scattered by our atmosphere, a glowing ceiling that hides the black. But the trouble goes deeper than air, even for telescopes in orbit. above the atmosphere entirely. The solar system itself is filled with a faint luminous haze. The space between the planets is dusted with countless microscopic grains, debris shed by comets and ground off asteroids over billions of years. And every one of those grains catches sunlight. Together, they create a soft glow that fills the inner solar system, called the zodiacal light. From a truly dark place on Earth, you can actually see it. A faint pyramid of light leaning up from the horizon after sunset. It is lovely. It is also, for anyone trying to measure the darkness of the universe, a catastrophe. It is like trying to judge how dark a distant forest is while someone holds a lit candle a few inches from your eye. The Hubble Space Telescope, magnificent as it is, orbits inside this haze. For this one particular measurement, the finest observatory of its generation was standing in the wrong place. To honestly measure the darkness of the universe, you would have to leave the haze, get past the dust, carry a camera beyond the glow of our own solar system's candle, and let it look at the black with nothing in the way. We had exactly one camera in a position to try. The New Horizons spacecraft launched from Cape Canaveral in January of 2006, one of the fastest launches ever attempted. And its mission was the one we touched at Pluto. In July of 2015, it swept past that dusk-lit world and gave humanity its first real portrait of it. The ice mountains, the frozen nitrogen plains, the thin blue hazes hanging above them. But like the Voyagers before it, New Horizons could not stop. It kept falling outward, on past Pluto, more than 4 billion miles from the Sun, out where the zodiacal dust thins away and the sky, at last, is clean. And a team of astronomers realized that this spacecraft, coasting through the outer darkness with working cameras, was holding the perfect instrument for the childhood question. Its long-range camera, designed to photograph Pluto, could be pointed at patches of sky chosen to be as empty as possible. No bright stars, no known galaxies dominating the view, and simply asked to measure what remained. How much light is left when you subtract everything you can name? The team was led by Toad Lauer of NSF's NOIR lab, the National Center for Nighttime Astronomy in the United States, working with Mark Postman of the Space Telescope Science Institute and colleagues, and their work appeared in the Astrophysical Journal, first in 2021 and then refined with more data in 2024. What they did with those images is a masterpiece of careful subtraction, the kind of patient bookkeeping that real astronomy is actually made of. They took the light in each frame and removed, piece by piece, everything that could be accounted for. The faint stars of our own galaxy, the scattered glow from stars just outside the frame, the dim reflection of starlight off the thin dust drifting through the Milky Way, every known source, one by one, deducted from the total. The question was, what would be left at the end of the ledger? If our catalogues of the universe are essentially complete, then, after subtracting everything, the remaining light should match the combined glow of all the known galaxies, and nothing more. The books should balance. The first analysis, in 2021, found something puzzling. After all the subtractions, there seemed to be light left over, roughly as much unexplained light as explained. A faint, anonymous glow with no obvious source. And for a few years, this was a genuine mystery, the kind astronomers love and lose sleep over. Was there a vast hidden population of galaxies out there? Too faint and too many to ever catalogue. Rogue stars adrift between the galaxies. Something stranger. Then came the refined measurement, published in 2024, using more images and a better accounting of one particularly sneaky candle, the faint veil of dust in our own galaxy that reflects starlight into every long exposure. With that improved bookkeeping, the mystery largely dissolved. The books very nearly balanced. The leftover light shrank until it was no longer meaningfully different from zero. The simplest reading of the final result is that the darkness of the universe, measured from beyond Pluto, matches what the known galaxies should produce. No vast hidden sea of extra light. Invisible light. The universe is about as dark as our maps say it should be. Pause on what that actually means, because it is easy to hear as an anticlimax, and it is anything but. First, savor the process itself, because this is science behaving exactly as it should. A strange result appeared. The researchers did not defend it or dramatize it. They gathered more data, improved their own accounting, found that the anomaly faded, and published that too. A mystery honestly dissolved is worth more than a mystery loudly kept. And stories like this one are the reason careful people trust astronomy. And second, sit with the finding itself. The total visible light of the cosmos. Everything, every star in every galaxy sends into the general dark, averaged across the enormous volume of everything, adds up to almost nothing. The measured background is a glow far too faint for any human eye to ever notice. A whisper of light, dimmer than the darkness inside a closed and buried vault. Take away the sun, the moon, the planets, and our galaxy's nearby stars, and the sky does not merely get dark. It gets darker than any night any human being has ever stood under, by an enormous margin. Invisible light, averaged over its vastness. The universe is black. The light we live inside is real, but it is gathered into rare, small, precious knots. And between the knots, the honest answer to the child at the window is this: space is very nearly perfectly dark, and we have now measured from beyond Pluto how near to perfect it comes. There is one more turn here, my favorite one. That faint, measured glow is not nothing. It is everything. It is the collected shine of every galaxy that ever formed, blurred together into a single, dim signal. The universe's entire luminous output in one reading. The darkest measurement ever made is also the most complete. One camera, 4 billion miles out, held a light meter up to all of creation at once, and all of creation barely moved the needle. Let that be a restful thought rather than a lonely one. The universe is not a blaze you are missing out on. It is a vast, dim, quiet place. And the warm lit room you are lying in tonight is genuinely one of its brighter corners. So the universe is dark on average, but an average can hide extremes. And now a sharper question opens. Are there places that fall below even that average? Regions so empty that even the rare knots of light thin out and fail. Not the dark between stars or between planets, but darkness at a scale where whole galaxies are the missing thing. There are, and in 1981, a team of astronomers doing patient, unglamorous survey work stumbled into one of the largest ever found, a cavity in the universe so enormous that it unsettled the people who mapped it. and so empty that one astronomer's reflection about it has stayed with everyone who has heard it since. To understand what was found in 1981, you first need to know what astronomers were doing at the time, because the discovery was an accident of housekeeping. Through the 1970s and 80s, astronomy was engaged in a grand project, making the first real three-dimensional maps of the universe. Photographs of the sky are flat. They tell you a galaxy's direction but not its distance. The way city lights, seen from an airplane at night, form a flat carpet with no depth. To add the third dimension, astronomers had to measure the distance to each galaxy one at a time, using the redshift we met earlier tonight, the stretching of light that reveals how far away a galaxy sits in the expanding universe. Picture the actual work, because it is worth picturing before we get to the size of what it found. A dome on a cold mountain, opened to the night. One person at the controls, another making notes. The telescope is aimed at a smudge of light so faint that it took the universe hundreds of millions of years to deliver it. And now the instrument must sit perfectly still and gather that trickle of light for an hour or more, while the dome creaks and turns to follow the sky. Then the light is spread into a spectrum. The stretch is measured. A distance is written down, and the telescope moves to the next smudge. One galaxy, one number, then another. Night after night, season after season, in the cold, for years. This is the census of the universe, and it was taken the way every real census is taken, one address at a time, by people who were tired. A team led by the astronomer Robert Kirshner, with several colleagues, was doing precisely this kind of survey, measuring galaxy distances in a few sample patches of sky in the direction of the northern constellation Bootes. The name, by the way, belongs to an ancient constellation of a herdsman, one of the old star patterns that has watched over northern skies since antiquity. They expected their patches to show the usual scatter, galaxies sprinkled along the line of sight at all sorts of distances. Near, middling, far. That is not what the data showed. In their measurements, galaxies appeared at nearer distances, and galaxies appeared at farther distances, and in between, across a colossal stretch of depth, there was a gap, almost nothing, as if the universe, along that line of sight, had a missing flaw. One strange gap in one patch of sky could be a fluke of small numbers, and the team knew it. They published their finding in 1981 in the Astrophysical Journal, cautiously, and then kept observing, widening the survey to test whether the gap was real. It was real. Follow-up. Work through the 1980s confirmed and mapped it. The gap was not a narrow tunnel, but a rounded region, present in patch after patch. A genuine three-dimensional cavity in the distribution of galaxies. It came to be called the Bootes Void, and its measurements are the kind you have to approach slowly. So let us do exactly that, with no hurry at all. The void is roughly 250 to 330 million light-years across, depending on where you draw its soft edges. That number cannot land on its own, so let me give it scale. Our entire Milky Way galaxy, with its hundreds of billions of stars, is about 100,000 light-years across. The Bootes void is roughly 3,000 times wider than our whole galaxy. In miles, its diameter runs on the order of 1 billion trillion miles or more. A 1, followed by 21 zeros, and then some. It is one of the largest and most famous cosmic voids ever mapped. A structure, if that is even the right word, made almost entirely of absence. A region of ordinary universe that size should contain, by the average density of the cosmos, on the order of 10,000 galaxies or more. Surveys of the Boots void have identified only around 60, a few dozen faint galaxies, scattered through a volume that should hold thousands upon thousands. It is not perfectly empty, and honesty requires saying so, but it is emptier than almost anywhere else we have ever looked. A place where the universe simply declined. On an unimaginable scale. To put things, where did it come from? Voids are a natural part of how the universe grew up, and the Boots void is a giant of the family. Cosmologists understand the broad picture well. In the young universe, matter was spread almost perfectly evenly, with only the faintest ripples of extra density here and there. Gravity then spent billions of years amplifying those ripples. Regions with slightly more matter pulled material in and grew richer. Weaving the glowing web of galaxies our maps reveal, regions with slightly less matter were slowly drained, their contents drawn away toward the crowded regions around them, growing emptier and larger as the universe expanded. The galaxy-filled universe is a web, and voids are its gaps, and the Boots void is among the greatest of those gaps. Why this particular void grew quite so large is still an open question, and I will not pretend otherwise. Possibly, several smaller voids merged long ago. What is certain is that it sits there now, mapped from many directions, no longer in any doubt. Now, I told you at the start of tonight that some of what you would hear would be genuinely unsettling, and that where the science is solid, I would let it be exactly what it is. This is the moment I had in mind, because the most haunting thing about the Boots void is not its size, it is a thought about what it would be like to live there. The astronomer Gregory Aldering, one of the researchers who studied the void's sparse galaxies, once framed it in a way that has been quoted ever since. And I want to give you the substance of his point carefully. If our Milky Way had formed near the center of the Boots void, the night sky would look normal to your naked eye, because every star you can see at night belongs to our own galaxy. Close at hand, the bedtime sky of that other Earth would be as starry and as beautiful as ours. But beyond the galaxy, there would be nothing near enough to find easily. The faint, fuzzy smudges our real sky offers. The Andromeda galaxy, visible to the naked eye on dark autumn nights. The companion clouds of the southern sky. The thousands of galaxies within reach of small telescopes. None of it would be there. Astronomers in that Milky Way, Aldering observed, would not have discovered that other galaxies existed until sometime around the 1960s, when their instruments finally grew powerful enough to detect anything across that ocean of emptiness. Sit with that, gently, for us. The discovery that our galaxy is one among many came in the 1920s. When Edwin Hubble measured the distance to Andromeda, it stands among the greatest single revelations in human history. The moment the universe became large, a civilization in the Boots void would have reached the atomic age, the space age, still believing their one galaxy was the entire universe, surrounded by a darkness that answered every question with nothing, their finest telescopes, for generation after generation, would have swept the deep sky and found it blank. And the strangest part is that they would have had no way to know anything was missing. The darkness would not have felt like a wall. It would have felt like the truth, which raises a question too honest to skip. How would we know our own view is not somebody else's boots void? The answer, and it is a good one, is that we keep checking. And everything checks out. Our maps go deep in every direction. They agree with one another. And the web of galaxies they reveal is real and richly populated. We are not the civilization in the void. We simply know, now, that such places exist. And when I sit with the boots void long enough, the shiver of it quietly turns over into something else. And I want to offer you that turn before we move on, because you have earned it. Consider what is actually inside that emptiness. No collisions, no radiation storms from crowded galactic neighbors, no noise, a few dozen galaxies drifting in a calm 300 million light-years deep, each one wrapped in more stillness than anywhere else in the mapped universe. If there are eyes on some world in one of those rare galaxies, they look out on the quietest sky there is. The void is not a wound in the universe. It is the universe's largest silent room. And you already know, from every hour of tonight, what tends to be true of the places that look most like nothing. The boots void is the darkness of absence at its greatest scale. Galaxies thinned nearly to zero across an ocean of space. But there is one darkness left that is deeper still, and it is not an absence at all. It is the oldest thing there is, because even in the emptiest region at the center of that void, far from any local star, with almost no matter of any kind, the universe would still not be truly empty of light. A faint glow would remain, arriving from every direction at once, older than the stars, older than the galaxies, older than the darkness itself. It was discovered by accident, in New Jersey, by two scientists who spent the better part of a year trying to make it go away. At one point, they thought it might be pigeons. In the spring of 1964, two young radio astronomers in New Jersey had a problem, and the problem would not go away. Arno Penzias and Robert Wilson worked at Bell Telephone Laboratories in Holmdel, New Jersey, and they had been given the use of a magnificent instrument, a giant horn-shaped antenna, 20 feet across. Originally built to catch faint radio signals bounced off early communication satellites, Penzias and Wilson wanted to use it for pure science, measuring faint radio emissions from the sky. And to do that, they first had to do what every careful scientist does. They had to account for every source of noise in their system, so that whatever remained would be real. They accounted for everything, and something remained, a faint, steady hiss. Everywhere they pointed, day and night, summer and winter, toward the Milky Way and away from it. The signal did not care about direction, did not care about the season, did not care about the time of day. It was as if the whole sky, every part of it equally, were very gently warm. They assumed, reasonably, that something was wrong with the antenna, and what followed is one of the most charming episodes in the history of science. Precisely because of how unglamorous it was, they checked the wiring, they checked the receiver, they pointed the horn at New York City to see if the hiss was urban interference. It was not. They considered stray radar, atmospheric effects, the metal of the horn itself, and then they noticed that a pair of pigeons was roosting inside the antenna, coating parts of it with what Penzias later described, in the polite language of physics, as a white dielectric material, So they trapped the pigeons, cleaned the horn, and listened again. Here were two careful scientists, holding one of the most important discoveries of the 20th century in their instrument, spending their days evicting birds and scrubbing metal, doing their honest best to make the discovery go away. The pigeons left. The hiss stayed. Meanwhile, and this is the part of the story that feels almost scripted, just 30 miles away at Princeton University, a team of physicists led by Robert Dick was preparing to search for exactly this signal. Theorists had predicted that if the universe began in a hot, dense state, an idea, then still carrying the half-mocking nickname, the Big Bang, then the glow of that primordial fire should still be out there, cooled and stretched by billions of years of cosmic expansion into faint microwaves arriving from every direction at once. Dickey's team was building an instrument to look for it. Then the phone rang. It was Penzias, describing a mysterious hiss they could not eliminate. Dick listened, hung up, and, as the story has been told by people who were in the room, turned to his colleagues and said, "Boys, we've been scooped." The two teams published side-by-side papers in the Astrophysical Journal in 1965, one describing the measurement, the other explaining what it meant. The hiss was the cosmic microwave background, the leftover light of the universe's beginning. Penzias and Wilson received the Nobel Prize in Physics in 1978. They had been annoyed, for months, by the oldest thing anyone has ever detected. Now, let me unfold what this light actually is. Slowly, because it belongs at the very center of tonight's story. Run the universe backward. Galaxy converge. Space contracts. And everything grows hotter and denser. Because compression heats. Go back far enough to within a few 100,000 years of the beginning, and the entire universe was as hot as the surface of a star. Not a universe containing stars, a universe that was itself, everywhere, star-hot. All of space glowed. There was no darkness anywhere, because there was nowhere for darkness to be. Every point in the cosmos blazed. A sea of light and matter mixed so densely that light could not even travel. Every ray was absorbed the moment it was emitted, trapped in the glowing fog. Then, about 380,000 years after the beginning, the expanding universe cooled past a threshold. Electrons and proton, which had been too hot and frantic to hold together, finally combined into stable atoms, and the fog cleared. Suddenly, light could fly free, and the glow of that moment was released in every direction at once, filling all of space. Cosmologists call this moment recombination, and the light set loose that day has been traveling ever since. That light is the hiss in the Holmdel horn, when Penzias and Wilson pointed their antenna at the sky. They were receiving photons that had been in flight for 13.8 billion years. Light older than every star, older than every galaxy. The direct glow of the universe's original fire, arriving at New Jersey. And this is the fact I most want you to carry from this chapter. That ancient glow does not come from a place. It comes from every direction equally, because it was emitted by everywhere. The whole universe glowed, so the whole sky delivers it. Beyond the local veils of gas and dust that drift through our own galaxy, the primordial glow fills the sky in every direction, with no gap anywhere. If your eyes were tuned to microwaves, the night would look softly luminous from horizon to horizon. The sky above your roof tonight is not truly black, and it has never once been truly black. It is a fading fire, seen from inside. Why can you not see it? Because of the quiet thief we met near the start of the night. Expansion. 13.8 billion years of stretching space has stretched this light along with it, pulling its waves more than 1,000 times longer, sliding them far below anything eyes can register, down into microwaves. And the stretching has cooled the radiation as it went. That original fire, once thousands of degrees, now arrives as radiation, carrying a temperature of only about 2.7 degrees above absolute zero. That is a property of the light itself, not of the vacuum it crosses. And in that sense, the empty sky has a temperature everywhere you point, in every direction. The darkness registers as faintly, measurably warm, and that warmth is the beginning of the universe, still arriving. Tonight, on your roof, on your street, on the fields outside your town, as steadily as rain. So, in one poetic sense, the old paradox of the burning sky was pointing at something real. The whole sky truly was, once, a wall of light, though for a completely different physical reason than the one Olbers imagined. A glowing newborn universe rather than an infinite forest of stars. We simply arrived late, and the fire has burned low. The darkness you see is not the absence of that light. It is that light, worn thin by time and distance, stretched beneath the threshold of your senses. Darkness, it turns out, is what the oldest light looks like after it has been traveling too long. One more gentle thing before we leave New Jersey. The glow is still fading. Every year, expansion stretches the background a little further, cools it a fraction closer to absolute zero, and it will go on fading, gradually, without end. The ember of the beginning is dimming. Nothing about that concerns your lifetime, or your children's, or any timescale with a human name on it, but it points a question forward, the last big question of our journey, the one everything tonight has been building toward. If the oldest light is fading, and the universe keeps stretching, where is all of this going? What does the sky become? In the very deep future. Science has a real forecast. It is strange. It is humbling. And, held the right way, it is one of the most quietly beautiful things ever worked out. That is where we go now. Every star is a fire, and every fire runs out of fuel. Our sun has been burning for about 4.5 billion years, and it is roughly halfway through its supply. In several billion more years, it will swell, redden, exhaust itself, and settle down as a white dwarf, a dense cooling ember about the size of the earth, shining fainter and fainter for ages. There is no urgency in this for you. It is simply what stars do, on timescales that make all of human history one held breath. But tonight, our subject is darkness. So let us follow the thread all the way, gently and honestly, and see where the universe itself is going. Cosmologists have genuinely worked on this, tracing well-tested physics forward. And while every forecast this deep is a model rather than a promise, the broad shape of it is taken seriously across the field. I will keep the uncertainties visible as we go. That is a promise I made you at the start of the night. Begin with a fact that surprises almost everyone. The universe's great era of star-making is already past its peak. Astronomers who study cosmic history have measured how the rate of star formation has changed across time, and their surveys agree that it crested around 10 billion years ago and has been declining ever since. The universe today forms new stars at only a small fraction of its former rate. The raw gas that stars are made from is slowly being locked away in old stars and dead remnants, and it is not being fully replaced. The cosmos is not in its morning, it is in its long afternoon, and the light across the fields is already turning gold. The evening ahead will be extraordinarily long. The smallest stars, the red dwarfs, are the great misers of the universe, burning their fuel so slowly that they can shine for trillions of years. When the bright, fast stars like our sun are long gone, the red dwarfs will glow on, dim and steady and patient. But even misers run dry eventually. Physicists, including Fred Adams and Gregory Laughlin, who in 1997 published a detailed study of the far future and later expanded it into a book called The 5 Ages of the Universe, have traced the timeline as the models describe it. Some 100 trillion years from now, give or take a great deal, the last stars gutter out, and the entire age of starlight, from the first star to the last, closes, if the models hold. Everything we think of as the luminous universe, every constellation, every galaxy in every photograph, belongs to one opening chapter in a book that is mostly quiet darkness. And while the stars burn down, the other process, the one we set aside earlier tonight, keeps working. The accelerating expansion keeps carrying distant galaxies over the horizon of visibility, beyond the reach of any signal, and every gap in the deep sky is a direction in which the universe is quietly closing its doors. Year by year, at the largest scales, the portion of the cosmos that can ever send us new light grows smaller. Cosmologists who model the far future find that in something like 100 billion to a trillion years, essentially every galaxy beyond our own gravitationally bound neighborhood will have been carried out of view, its light stretched and dimmed into undetectability. Our neighborhood itself, I should say clearly, is safe from all of that. Gravity binds it. The Milky Way and its companions will stay together regardless of what expansion does to the wider universe. And here I need to update a story you may have heard many times, because science has genuinely moved on this point, and moved recently. For years it was standard to say that our galaxy and the great Andromeda galaxy, which are approaching each other, will collide and merge in about 4 to 5 billion years. That collision was presented as a near certainty, and it may yet happen. But a careful study published in 2025, using refined measurements of the galaxy's motions from the Hubble and Gaia space telescopes, and accounting for the gravitational tug of their neighbor galaxies, found the future far less settled. Across the researchers' simulations, the chance of a merger within the next 10 billion years came out close to a coin flip, and a collision within 5 billion years looked genuinely unlikely. Other teams, using different corrections, have since argued the odds may be higher after all. The honest summary tonight is that nobody knows. The two great galaxies are approaching. A merger is possible, and in some models, likely, and the question is open in the best way, with better data on the way. I find that more comforting than the old certainty. Truthfully, even the largest collision in our future is still, politely, undecided. Now put the deep forecast together and picture, as the models picture, the sky of a truly distant tomorrow. Imagine astronomers, of whatever kind, on a world circling some old red star in our galaxy. 1 trillion years from now, their night sky still has stars, the long burning dwarfs of their own galaxy, so their night is not black, and their bedtime skies are still worth looking at. But beyond their galaxy, they detect nothing. No other galaxies reward their finest instruments, and the cosmic microwave background, the fossil light that told us our origin story, will by then be stretched so thin and faint as to be essentially beyond reach. Here is the thought that the scientists who study this genuinely wrestle with, and it deserves to be said carefully. As a projection rather than a prophecy, those future astronomers, however brilliant, may have no way to discover the expansion of the universe, no way to detect the glow of the beginning, no way to learn that other galaxies ever existed. The evidence will have left. They would look out with perfect instruments and perfect reasoning and conclude, reasonably and wrongly, that their one island of stars floats alone in a static dark. It is the civilization of the Boots Void, no longer as a thought experiment, but as the standard address. Everywhere, if the models hold, the universe, in its deep old age, may slowly put away the records of its own youth. I promised that the unsettling parts of tonight would be honestly presented, and this one is presented exactly as science holds it. A sober projection from well-tested physics, with its uncertainties attached, held one way. It is melancholy, but turn it over, because it has another face. And the other face is the reason I brought you here. If the deep future is likely to know less, then we are the ones who know. Think about what this era, this narrow, bright morning of the cosmos, actually offers. The galaxies are still within view, billions of them. The first light of creation still falls on New Jersey. Faint but measurable, the sky still carries. Legible to anyone who builds the instruments. The entire story of where everything came from. We happen to exist inside the reading window. The era when the universe can still be read from cover to cover. That was not owed to us. It is simply the view from now. And tonight, you are one of the people standing at the window, taking the view, and there is one more mercy in the forecast. The one I want you to actually fall asleep on. Everything described in this chapter. The last star, the emptied sky, the fading of the first light, unfolds across spans of time so vast that every event in human history, from the first campfire to this sentence, is less than an eye blink against them. The stars you can see from your window will outshine every nation, every language, every monument on this planet, by billions of years. On every timescale, a human heart can genuinely feel the lights are not going out. For you, for everyone you will ever meet, and for their descendants beyond counting. The night sky is effectively eternal. The long evening of the universe is real, and it is also none of your concern tonight. You may set it down, so here we are, at the bottom of the night, and the promise of the title has been kept in full. The darkness of space, honestly measured, honestly faced, and yet you may have noticed something happening along the way. Chapter by chapter, almost without announcement, every darkness we visited turned out to be holding something. water in the black craters, newborn stars in the black clouds, a golden record kept safe in the interstellar black. The whole story of creation, glowing faintly in the black between the stars. That pattern has repeated too many times tonight to be a coincidence. It is time to say plainly what it means. And the saying begins very close to home, with the darkness that visits you every single night of your life. The one that is, right now, quietly working on your behalf. Come all the way home now, back from the voids and the deep future, back through the clouds and the craters, back down through the atmosphere, through the glowing ceiling of scattered light, into the room where you are lying right now. Because the most important darkness in the universe, for you, tonight, is not out there. It is the one behind your eyelids, and the one filling the room around you. And after everything we have seen, it is time to tell the truth about ordinary night. It is not merely the absence of day, it is something your body actively depends on, as it depends on food and water and rest. And it is asking for it right now, in a language older than words. Here is the machinery, and it is beautiful. Deep in your brain, just above the point where your optic nerves cross, sits a cluster of about 20,000 neurons called the suprachiasmatic nucleus. It is tiny, about the size of a grain of rice, and it is the master clock of your entire body. Nearly every process you have runs on its schedule. Your temperature, your hormones, your digestion, your alertness, your repair work, all of it rises and falls on a roughly 24-hour cycle that scientists call the circadian rhythm. From Latin words meaning about a day. The science of this clock is thoroughly established. The 2017 Nobel Prize in Physiology or Medicine went to 3 American scientists, Jeffrey Hall, Michael Rosbash, and Michael Young, for uncovering its molecular gears, the actual genes and proteins that tick inside nearly every cell you have. And this is the detail that ties your own body to every chapter of tonight's journey. That master clock sets itself by darkness and light. Your eyes contain a special class of cells, characterized only around the turn of this century, whose primary job is not forming the images you consciously see. They do not help you read or recognize faces. What they do is report to the clock, telling your brain one thing above all: how bright the world is. As evening arrives and light levels fall, those cells quiet down, and the circadian system allows a hormone called melatonin to rise on its nightly schedule, the chemical signal of night. Melatonin climbs. Your core temperature eases downward, and your whole body begins the nightly turn towards sleep and repair. This is happening to you at this very moment. If your room is dark, darkness works on your body almost the way a nutrient would. That is a metaphor, of course, but the biology underneath it is entirely real. Darkness is a signal your body has evolved to expect, and when the signal arrives on time, an entire nightly program of rest and maintenance is allowed to run as designed, which is why the story from our first chapter, the story of the vanished night, turns out to be about more than stargazing. When we wrapped the inhabited world in permanent glow, we did not just hide the Milky Way. We began confusing the clock in every human head. Light at night, especially the blue, rich light of screens and modern lamps, presses on those reporting cells and delays the melatonin signal. essentially telling your brain that the day has not ended. Research on this has grown into an entire field. Organizations from the American Medical Association, which issued formal guidance on the health effects of nighttime lighting in 2016, to sleep researchers at universities around the world, have documented the pattern. Disrupted darkness disrupts sleep, and disrupted sleep touches nearly everything: mood, memory, metabolism, the immune system. Honest scientists are careful about how far each specific claim reaches, and so will I be. But the core of it is not in dispute. Your body was built, over millions of years, for a planet with real nights, and it still expects them. Earth's ordinary darkness does not heal you the way a medicine does. It does something quieter. It makes restoration possible. By creating the conditions your body's own nightly repair requires, there is something almost tender in that. All night we have travelled through darkness as spectacle. Darkness measured in light years and billions of years. And the humblest darkness of all, the plain dark of a bedroom, turns out to be doing quiet, faithful work on you every night of your life. The 2-week night of the moon defeats machines. The ordinary night of Earth makes restoration possible. Same absence of light, a very different effect, and people are beginning to remember this. In a movement I want to tell you about, because it may be the most hopeful thing in tonight's whole story. Around the world, communities have started protecting darkness the way earlier generations protected forests and rivers. There is an organization, founded in 1988 in Tucson, Arizona, called the International Dark Sky Association, now known as Dark Sky International, and it certifies places that commit to preserving natural night, places with careful lighting, shielded lamps, real darkness overhead. They are called dark sky parks and dark sky reserves. And there are now more than 200 certified places across the world. The first international dark sky park ever named, back in 2007, was Natural Bridges National Monument in Utah. And what happened next in that corner of the American Southwest is worth telling, because it shows what this movement actually looks like on the ground. Whole towns began changing their lights. Communities across southern Utah, including small gateway towns near the national parks, went through their streets fixture by fixture, replacing lamps that threw light upward with shielded ones that aim it down where people actually need it, choosing warmer bulbs, dimming what did not need to be bright. None of this made those towns darker on the ground. In many cases, the streets became easier to see because glare went away. What changed was overhead. The sky came back. Places like Death Valley in California and Big Bend in Texas now hold some of the darkest certified skies in the United States. And in Europe, the other home of so many of you listening tonight, the idea has taken hold just as firmly over the moors of Exmoor in England, across the mountains of Banau Brycheiniog in Wales, in the West Haviland countryside, barely an hour from the lights of Berlin. Notice what this actually is. After a century of pushing darkness away, human beings are driving hundreds of miles, crossing oceans, paying for the privilege of standing in it. Darkness has become a destination. The thing our ancestors huddled against the fire to escape is now the thing we protect with ordinances and cherish with pilgrimages. I do not think this is a fad. I think it is a species quietly realizing it misplaced something it needs, and beginning carefully, to bring it back. So the case is closed on the question this chapter opened. The darkness that visits you nightly is not an emptiness that sleep merely happens inside. It is an active, expected presence, a signal your body has been waiting for since sunset. The standing conditions for a nightly repair that has kept your ancestors alive for 1,000,000 years. When you turn off the last light tonight, you are not shutting something out. You are letting something in. Feel free, in fact, to let your body respond to that sentence however it wants to. It knows what to do with darkness. It has always known, and with that, every piece of tonight's story is finally on the table. We have seen what darkness is, where it lives, what it holds, and what it does. There is only one thing left, and it is the thing I have been waiting all night to do with you. It is time to gather every thread, from the caves to the craters to the voids to the clock ticking softly behind your eyes, and weave them into the single idea they have all been pointing toward. The idea this whole night was secretly about. Let me tell you what I believe this entire journey has been about. Underneath everything, at the start of tonight, I made you a quiet promise that the darkness of space, honestly faced, would turn out to be a gift. We have now walked far enough that I can keep that promise not with reassurance, but with evidence. So gather just a few of the chapters back for a moment, the essential ones, and look at what they have in common, not what they showed us. How they showed us. Consider the James Webb Space Telescope, the deepest views of the universe in human history, 13 billion years down into time. How were they achieved? Not with more light, with darkness. Webb sees because it hides, resting in an engineered night behind its silver shield, chilled colder than Pluto, because the faint heat of the ancient universe can only be sensed by an instrument that has first silenced its own glow. Every one of those images of infant galaxies was taken from inside a shadow we built on purpose. Consider your own eyes. In the cave at the start of the night, 16 times more open in darkness, retinas shifting their very chemistry, capable, by some estimates, of catching a candle across miles of night. But only after half an hour of real dark. The instrument was always this good. It was waiting for permission. And the permission is darkness. And consider that camera beyond Pluto, the one honest measurement of all the light in the universe, could not be made from Earth, and could not be made from Earth's orbit, because our own solar system's dust glows like a reading lamp left on in the hallway. The measurement had to wait until a spacecraft had traveled beyond the glow, into a sky finally dark enough to tell the truth. 3 instruments. A telescope, a human eye, a deep space camera, and one rule governing all 3. The rule this whole night has been quietly demonstrating. Every revelation in tonight's story required some form of quiet first. Reduced glare, lowered heat, thinned foreground. An antenna in New Jersey scrubbed of every competing noise down to the pigeons. A photographic plate exposed on a black country night, far from any city. The forms differ, but the principle never does. The faint, the deep, and the far away can only be received against stillness. And darkness is simply the stillness of light. You know this rule already. From your own life. You cannot hear a whisper at a concert. You cannot feel your own heartbeat while running. The quietest signals need the quietest rooms. So We have the whole thing backwards when we speak of darkness as the thing that hides the universe. It is the opposite. Darkness is the thing that reveals it. Sunlight, for all its warmth, is a kind of magnificent blindness. Stand in full daylight, and the universe shrinks to one star. The other 100 billion stars of our galaxy are still overhead at noon, shining exactly as they do at midnight. And you cannot see a single one, because the scattered glow of our one nearby star has flooded the instrument. Daylight does not show you the universe. It shows you the sun, reflected off your surroundings, and hides everything else that exists. It is only when the planet rotates you into its own shadow, only when the local lamp is set down behind the horizon, that the true situation becomes visible. The stars come out, we say, but of course they do not come out at all. They were always there. You come out. Night is not when the universe appears. Night is when you can finally see that it never left, which gives the title of tonight's journey its final, honest answer, the terrifying reality of how dark space really is. The unsettling parts were real, grounded in published observations, and where the far future remained a model rather than a certainty. I said so. Space is dark, almost beyond measuring. The blackness begins at the top of the sky and, for every practical purpose, never ends. The voids are real. The last stars will someday gutter out if the models hold, and the deep future may know less than we do. But walk through all of it, as you now have, and the terror quietly inverts. The darkness of space is the reason we know any of this. A bright universe, a universe of Olber's burning sky, would be an unreadable universe, a wall of glare with all its depths erased, and no one beneath it would ever have discovered so much as a second star. The darkness is not the price we pay for the view. The darkness is the view we see because it is dark. It may be the single most generous fact about the cosmos, and it is the fact everyone fears. There is a last step to take tonight, and it is the gentlest one. We have understood the darkness now, measured it, mapped it, traced it from your bedroom to the edge of everything. But understanding is not the same as standing under. One experience remains, the one this entire journey has quietly earned. And I want us to have it together before you sleep. I want to take you, in imagination only, to one of the last perfectly dark places on this planet, on a clear, moonless night, and let you finally see what has been waiting above the lampshade all along. Bring your blanket. It is cold where we are going, and the sky there is unlike anything you have ever been shown. The place I have chosen for us is real, and you could go there someday if you wanted to. It is the Atacama Desert in northern Chile, a high plateau squeezed between two mountain ranges, the driest non-polar desert on Earth. Some weather stations there have gone years without recording rain. The air is thin. The villages are few and far between, and at night, over vast stretches of that plateau, there is no artificial light at all. The world's great observatories have gathered there for exactly the reasons you now understand better than most people alive. The European Southern Observatory operates its largest telescopes on those mountains because the Atacama offers some of the darkest, clearest, steadiest air on the planet. It is, by the measures that matter to astronomers, one of the best places on Earth to stand and look up. So let us stand there together, in imagination. It costs nothing. And imagination, as you have seen all night, is how every one of these journeys actually begins. It is a moonless night, sometime after midnight. You have travelled far from the last village, and you have done the one thing this experience requires, the thing almost nobody has the patience for. You have turned off every light, every screen, every glowing thing, and you have simply waited because you know, from the very first chapter, what is happening in your own eyes during that wait. The pupils opening wide, the retinas quietly changing their chemistry, shifting to the deep sensitivity they were built for and so rarely get to use. It takes about half an hour. Most people never give it 5 minutes. You are giving it the full time, wrapped in your blanket, breathing the cold, clean air. And the sky above you is developing slowly, like a photograph in a tray. At first, in the early minutes, it looks like a very good night sky. More stars than you have ever seen from home, sharp and unblinking in the dry air. Then it keeps going. Stars keep arriving. Faint ones fill in between the bright ones, and fainter ones between those, until the familiar constellations begin to drown. This is a real effect that experienced stargazers describe from truly dark sights. The patterns you learned as a child become hard to find because they were drawn for poor skies, built from the handful of stars that survive city glow under a real sky. Those handholds are swamped by thousands of neighbors. People seeing this for the first time often report a moment of genuine disorientation. And I want you to let yourself feel it, because it is the whole night's lesson arriving in your body. You have not been seeing a thinned-out version of the night sky your whole life. You have been seeing a different sky altogether. A rough draft. This crowded, blazing ceiling is the original. And then you notice the thing no photograph has ever quite prepared anyone for, stretching across the entire dome of the sky, from one horizon to the other, is a river of soft light, the Milky Way, not the faint grey smear that people in dark suburbs sometimes glimpse and feel lucky about. From the Atacama, on a moonless night, the Milky Way is a structure. It has texture, bright shoals and dark channels braided together. And you recognize the dark channels now, because you know them personally. That black rift running down the river's spine is the Great Rift, the dark nebulae, Barnard's clouds, thousands of light years of star, making dust with new suns kindling inside. In the southern sky hangs the coal sack, the head of the celestial emu. And you know what the emu is made of? You are not looking at patterns anymore. You are looking at objects whose stories you hold, and that changes what seeing feels like. The river is bright enough, from a place like this, to matter. Visitors to the darkest sites sometimes report a faint sense that the Milky Way itself lifts the darkness of the ground, that once the eyes are fully open, the sky alone begins to hint at the pale shapes of the landscape. Whether or not your own eyes could ever quite manage that, stand for a moment in what it would mean, the gathered light of 100 billion suns, arriving across thousands of years, received by 2 small instruments that evolution shaped for exactly this kind of night. And here is what I most want you to feel. Standing in our imagined dark, every chapter of tonight is above you at once. In a single view, the zodiacal light leans up from the horizon, the glowing dust of our own solar system, visible from a place this dark as a soft pyramid among the stars. The blackness between the stars is Poe's message. The finite age of everything, readable with your naked eye, beyond the river of the Milky Way, in directions you now know by name. The great voids hold their stillness, and, falling on your upturned face, far too faint to feel, far too stretched to see, the oldest light there is arrives from every direction at once. 13.8 billion years old. The glow of the beginning ending its journey on your skin. Nothing above you, not 1 cubic mile of it, is anything other than what you have spent this whole night learning it to be. Not a menace, not an emptiness. A window, open for now, with you standing at it. People who have this experience, the full version, dark, adapted, under a truly dark sky, very often say the same two things afterward. They say they felt small, and they say that feeling small did not hurt. I think tonight explains why. The smallness is real. One warm body under an ocean of black, but the ocean is not what people fear it is. It is the thing that forged, inside ancient stars, the calcium of your bones and the iron of your blood. It is the thing your eyes were tuned for across 1,000,000 years of true nights. It even keeps, in its coldest and gentlest archive, a small golden record with our music on it. You are not a stranger standing under the darkness. You are the darkness's own work. Briefly awake, looking back at it, feeling small under that sky is not the feeling of being lost. It is the feeling of being located. Precisely. At last, stay as long as you like. The desert is patient, and the sky does not close. But it is late now, truly late. And the last chapter of tonight is not in Chile. It is in your room, where it has been waiting all along. Come back now, gently, out of the desert, back across the ocean, back down through the glowing lampshade of the sky, into the dark room where you actually are. Notice it for a moment. This ordinary darkness, the one you did not have to travel anywhere to find. Strictly speaking, of course, darkness is not a substance. It is not an ocean, and nothing flows from the boots void to your bedroom. A careful physicist would tell you that darkness is simply a condition, light absent, or blocked, or scattered away, or too faint for your eyes to receive. And the careful physicist would be right. And I promised you honesty. So there it is. But conditions can be shared. And the condition in your room tonight, this same quiet absence of light, is the condition that fills the shadow cone outside your window, and the long night on the far side of the moon, and the calm around Voyager, and the great stillness of the voids. In imagination, and imagination has carried us faithfully all night. The darkness in your room is a small bay opening onto that larger ocean. You have spent tonight sailing to the far side of something that begins at your ceiling, and you know what it is now. That has quietly changed over these hours, and it will not change back. The dark above your roof is a window that will stay open for longer than your species will need. The dark behind your eyelids is a signal, already at work, already telling the oldest clock you own that the day is over and the repairs can begin. Nothing in the darkness around you is waiting, or watching, or hungry. It is simply the original condition of almost everything. Resting, the way it has rested for most of 13.8 billion years. The way it will go on resting, whether or not anyone understands it. Though tonight, in one small room, someone does. If tonight's journey gave you something, a like or a subscription is a quiet way to help others find it. And that is the only mention I will make of it. Because the rest of this hour belongs to you and the dark. So here is your last thought to hold. The softest one I know. Every single night of your life, you perform a small version of what the universe does. You turn down the light. You grow quiet. You let the faint things surface. The slow thoughts. The deep repairs. The dreams. All the things that daylight drowns. Sleep is your own personal darkness, doing for your mind what the cosmic darkness does for the sky, revealing what the glare of the day kept hidden. You are not falling into nothing tonight. You are falling into the oldest, most productive quiet there is. The universe is out there now, exactly as we left it. The water is keeping cold in the black craters of the moon. The new stars are warming in their dark clouds. Voyager is coasting, silent and safe, with its golden record facing the long night. The first light of everything is still falling. Everywhere. Softer every year. Patient beyond all understanding. None of it needs you awake. Turn off the last light. If it is still on, let your eyes do what they were built to do. The dark is not the end of seeing. It is how seeing begins. Good night.